Hello and welcome to today's webinar. I'm glad you could join us. My name is Mojmír Kučera and I work as a technical consultant for stamping processes. Today we will explore the key properties and benefits of Daido Steels for the metal stamping industry. This webinar is organized in collaboration with Gebrüder Becknagel GmbH, the exclusive representative of Daido Steel in Germany. Our goal is to provide insights not only into the materials themselves, but also into their practical applications and benefits for your production processes. Before we dive into the main topic today, I will quickly go through today's agenda. So today I will introduce the Daido Steel. Before that, I will introduce Gebrüder Becknagel. Then will be the main topic of this webinar. It will be presentation of Matrix Tool Steels. And through the webinar, feel free to ask any questions. In the end, we will try to answer it. So please send us some questions. And I'm not here alone today. I'm honored to introduce Matej Denis, who serves as Head of Application Technology and Head of Business Development for Special Materials at Gebrüder Becknagel GmbH. Hello, Matej. How are you today?
Hi, Mojmír. Thank you. I'm fine, and I hope you're doing well too. Yeah.
I'm great. Thank you. So Matej has extensive experience in material development for metal and forming technologies, and today he will share valuable insights on how Daido Steels can help enhance the performance and durability of your tools. So before we dive deeper into Daido Steels, I'd like to introduce Gebrüder Becknagel GmbH. This company has been in the industry for many years, specializing in high-quality precision steels for various industrial applications. In high-quality precision steels for various industrial applications, as I said. As a strategic partners of Daido Steel in Europe, they provide innovative solutions for metal technologies. And I have a short video about this company, so I will, just 1 minute, I will play the video right now.
Gebrüder Becknagel, your trusted partner for high-quality steels and precision tooling solutions. With over a century of expertise, we seamlessly blend tradition with cutting-edge technology to deliver outstanding performance. Our range of tool and structural steels is engineered to meet the highest industry standards, ensuring exceptional durability, wear resistance, and reliability in even the most demanding applications. Whether it's stamping, machining, or specialized tooling, our materials are designed to maximize efficiency and extend tool life. With a strong commitment to innovation and customer satisfaction, we provide tailor-made solutions that enhance productivity and streamline industrial processes. Our expertise and flexibility allow us to adapt to the unique needs of each client, making us a preferred partner in the global manufacturing industry. Gebrüder Becknagel, precision, performance, and quality you can trust.
Okay, that was a short video about Gebrüder Becknagel. Gebrüder Becknagel is a family-owned company based in Christies, Germany, specializing in the production and processing of high-quality tool steels. But for today, is more important that this is a representative of Daido Steel company, and when we will speak about Daido Steels, it's a Japanese company specializing in the production of special steels and alloys with a significant focus on the automotive industry. They produce special steels, forged parts, bearings, magnetic materials, and of course steels for cold and hot stamping. You can see on the screen the number of employees, so it's a quite big company, Daido Steel. And as I said, they specialize even in the steels for cold stamping. So Daido tool steels lineup for cold stamping and forging includes D2 matrix high spent steel and original steel grades with high hardness and toughness. Maybe you know the DCMX, which is the most famous steel from Daido for the stamping industry. And also they produce these steel tools for hot stamping. So Daido tool steels lineup for hot stamping dies includes H13 and other special grades that can provide excellent high temperature strength, softening resistance, and thermal conductivity. So Daido Steel has this is a basic, presentation of Daido Steel. And now that we have a basic overview, let's move on to the main topic: how Daido Steel can take your stamping processes to the next level. And with that, I would like to hand over the presentation to Mataj Danis. So, Mataj, this is your turn. Go on.
Thank you, Moimir. First, thank you so much for introducing Daido Steel and also Gebrüder Recknagel Präzisionsstahl and also my person. And it's an honor for me to stay here today and introduce the steel grades. And thank you so much for organizing this webinar. Yeah.
Thank you.
So let's go forward with the next slide, please. Yeah. What are we looking today? We are focused on the matrix steel grades. First of all, the very important steel grade is DCMX. DCMX stands for Daido Cold Work Matrix Steel. That's number one, most important steel grade. The next three steel grades are HSS high-speed steels, called the Dream series from Daido Steel. DRM stands for Dream 1, Dream 2, and Dream 3. DCMX is a conventional steel grade, and the other steel grades, the Dream series, are all ESR remelted steel grades. The next slide. Yeah. First of all, can we make it a little bit bigger the screen?
Yeah, I will try it. This one. It's better?
Yes, but now I have my own picture and the. So
maybe this one.
Yeah.
Is that better?
Perfect.
Yeah.
Yeah.
Okay.
Now it's perfect.
Yeah. Okay.
So let's go forward. The lineup of Daido steel grades for DCMX, you can see on the y-axis the toughness, on the x-axis the strength, and the location, the positioning of D2 grade 1.2379 is in the middle of the gray area. And above there, you can find the positioning of DCMX. That means DCMX is running in the same strength range like D2 grade with a hardness of 60 to 62 HRC, but the toughness is much higher than D2 grade. That's very important to know. Let's go forward. Yeah, it's very important to have a look on the chemical composition. In the first line, you can see the D2 grade 1.2379, and the yellow marked positioning is the DCMX, and the chemical composition is different to D2 grade. The most difference is between the carbon contents. DCMX just 0.6% carbon, and also the carbides building elements like chromium and vanadium are limited. Chromium up to 6.6%, and very special, very interesting is that DCMX has content of sulfur, and in this case sulfur is very important to improve the machinability, and the sulfur content is very limited, like the salt in a soup, and it has no negative impact, no bad impact to the mechanical properties. That's very important to know about it. It's just to bring up the machinability. We will see it a little bit later in the slides. Yeah, so let's forward. What are the main failure modes in the stamping process? I'm sure you all know the problems. That's your daily business. First of all, of course, if you use coatings, PVD coatings, you have mostly a problem of peeling of these coatings, and also problem of galling. If your working material is copper alloys, or aluminum, or other steel grades, like don't know the English word for
maybe aluminum,
like aluminum, or there's a problem of galling, of course, and most problem in stamping process is wear. It's the main problem, and of course the picture right, the bottom is the chipping, or in this case it's more a massive break of a punch. That's also a big problem in the stamping process. Yeah, so let's go forward, please. What are the main advantages of DCMX? Of course, we have only fine carbides in the matrix, and for the die performance, it's very important to have a high hardness of 60 or 62 HRC. For the stamping process is very important, and of course we need a high toughness to prevent chipping, to prevent galling, and to prevent a massive break. And for the die making, it's very important to have small distortion and very isotropic dimensional change during the die making process. And of course, for the die making, it's very important to have a very easy machining. It should be much easier than with D2 grade. I'm sure you all have your problems with the machining with D2 grade. Yeah. Next, please. What are the main applications of DCMX? Of course, all kinds of punches, dies, and for cold working applications, like cold stamping dies, blanking punches, where you have problems with galling and chippings and massive breaks. And if you use or if you produce segmented stamping dies, or if you need cutting plates, segmented cutting plates, you have always a problem with retained austenite, with growing during the heat treatment or during the production process. Those are the main applications where DCMX is a good idea to use. Yeah. Next, please. Very important is to take a look on the microstructure of DCMX. This picture shows us the microstructure of 3 grades. On the left side, you can see the D2 grade. The name DC11 is internal name from Daido Steel. It's the original 1.2379 D2. And you can see in the picture the linings of the carbides, the linings of the coarse carbides. You can see the very big coarse carbides, and this is always a problem with D2 grade. In the middle, you can see the DC53. It's also internal name for an 8% chromium steel grade. I'm sure you all have a different kind of 8% chromium steel grades in your countries from a lot of different manufacturers like Böhler, Udeholm, Kind, and so on. Yeah, and very interesting. Yeah, in the middle, the situation with the coarse carbides is much better than with the D2 grade. We have also some linings, but the linings are more finer, and also the coarse carbides are more finer. But the situation with DCMX is really much better. You can't see any coarse carbides. You have no linings with the carbides. It looks a little bit like a powder steel microstructure in the matrix. But DCMX, of course, is not a powder steel. It's a conventional steel grade, but the microstructure is very close to a powder steel grade. And in this picture, you can see also the fine black linings, and those linings are the sulfur content. And as I mentioned, the sulfur content has no negative impact into the mechanical properties. It's just to bring up the machinability of DCMX. Next, please. Yeah, what about the distortion during or after the heat treatment? I guess this is a very important chart, because a lot of our customers switching to DCMX because of the distortion, of the better distortion situation of DCMX compared to 2379. This chart shows us the distortion on the y-axis. We can see the size distortion in percent, and the x-axis we can see the tempering temperature, and we have the blue lines for D2 grade. The filled triangle is for the distortion in length direction of D2 grade, and the empty triangle is the line for the distortion in thickness direction and width direction. And as you can see, you have always a gap, a big gap between the length distortion compared to the thickness distortion. If you use a temperature about 480 degrees, or if you use the higher tempering temperature, it's all a big gap between length and thickness. And the situation with DCMX is absolute different. You can see the both points for length and thickness distortion are on the same level. If you use the temperature about 500 degrees, or more common about 520 to 540, you have always a very isotropic distortion of DCMX. And that means if you produce, for example, a cutting plate, or if you have a punch, a segmented punch, where you need a very small distortion, your product will fit much more better than with D2 grade. That's the point of this chart. Yeah, let's go forward. Yeah, what about the impact toughness? It's very important to understand that the most problem, or the most negative impact for the toughness, are the coarse carbides, the primary carbides. And as the picture in the bottom with the hammer shows, it's the most killer of the toughness are the primary carbides. That's the point you have to understand. What's about the situation with our steel grades like 2379 and 8% chromium steel grade and DCMX? And if you remember the microstructure, D2 grade has a lot of linings, a lot of coarse carbides, primary carbides, and the situation with the toughness, as you can see on the picture, is the blue line for D2. You can use a very low hardness of 56 or 50 HRC, or you can go up with your hardness to 60 or 62 HRC. You have always a very low level with your toughness. The situation with a DC53 or an 8% chromium steel is better, much better, because of the finer linings. But the situation with DCMX is so much different. If you use the highest hardness of 62 HRC, you have more toughness than with the other grades. But if you reduce your hardness back to 60 HRC, you will earn so much more toughness for your punch, for your stamping process. That's outstanding. Yeah. And the reason is very clear, I guess, because of the very, very fine microstructure without big carbides. you will earn so much more toughness with DCMX. Let's go forward, please. Yeah, what can I tell you about the wear resistance? First of all, you have to know that it's not possible to have a steel grade, a conventional steel grade with the best toughness and also with the best wear resistance. That's not possible. That's physics. But it's also important to know that the wear resistance of DCMX works in the same way. You can get the same results as with D2 grade. The advantage of DCMX is that you can use a higher hardness, and with a higher hardness you can reach the same wear resistance level like D2 grade. And the advantage is also that DCMX has much more finer carbides than D2, and also the space between the single carbides is very, very small. And that's important to have better wear resistance. And of course, also in case of galling, if you have a problem with galling, the space between the single carbides is very important. If you have a big space between the linings, the carbide linings, like you have with D2 grade, you have a big problem with galling. And if you have a smaller lining or very small space between the single carbides, you have less problems with galling. And the situation with DCMX is for galling absolute better than with D2 grade. Yeah. Let's go forward. The machinability, as I mentioned in the beginning, is really outstanding with DCMX. The pictures below shows us the chips during the building process. It's in annealed condition, that means rough machining. And you can see for the D2 grade, we have dark blue colored chips. That means we had a very high temperature in the milling process. And on the right side, the right picture shows the chips during the milling process, and the color is much brighter. And that means we had a lower temperature during the milling process. And the reason is, of course, because of the finer carbides we have with D2 grade higher wear on the tool, and the temperature was going more and more up with D2 grade. And the situation with DCMX is completely different. Yeah, the temperature is on a lower level, and that means the machinability is better, and also the wear on your cutting tool is also less. Yeah, and for the machinability, I would like to add some information. At the moment, we are on some case studies. We do some trials, machining trials, machinery trials for the Daido Steel grades for DCMX and the Dream series. And we will publish the trial next time. And I guess we can share some more information for the machinability of DCMX and the other steel grades. Yeah. Next, please. This chart shows us the machining properties in the annealed condition on the left side, and on the right side we have the milling properties in heat-treated condition. And as we can see, the machinability of DCMX compared to D2 grade is in annealed condition 3 times better, and in the hardened condition it's 6 times better than with D2 grade. The measurement was about the cutting length, and I guess it's very impressive to see that the machinability of DCMX is so much better than with D2 grade. And this is one of the most reasons why customer switched from D2 grade to DCMX, because of the much better machinability of DCMX. Yeah. Next, please. It's very important to know that the heat treatment of DCMX is very easy. It works in the same way like D2 grade, and I'm sure every heat treatment company that is able to harden D2 grade is also able to make the heat treatment for DCMX. The quenching temperature is about 1030 up to 1050 degrees, and the tempering temperatures between 480 and 560 degrees. You have to use 3 times tempering, but this is, I guess, this is an absolute standard in Germany and in Central Europe. And it's important to use a tempering temperature to stay on the right side on the of the secondary hardening maximum. Because if you use tempering temperature lower than 520 degrees, you will create some retained austenite, and therefore you have to make sure that the retained austenite switches to martensit, into martensit. Yeah, and if you use tempering temperature lower than 520 degrees, it's sometimes very useful to get into the deep cooling to make sure that the retained austenite switch into the martensit. Yeah, the next, please. What are the main applications for DCMX? Of course, because of the small distortion, it's very useful for very big dies where small distortion is required, and also for large dies, large dies, yeah, and dies where they are segmented, or for big cutting plates. It's also very important and very useful to switch to DCMX. And because of the high toughness, of course, for all kind of dies where chipping is a problem, where cracking is a problem, and also we have a lot of customers, they use DCMX in case where the shape is very complex and complicated. Yeah, and as I told, of course, the high machinability is one of the main reasons why customers are using DCMX for dies. And if you have a milling job where you have a lot of milling, a lot of drilling or something else, turning, you will save so much money during your production process. And if you want to reduce galling, you can, of course, use DCMX. And if you want to reduce abrasive wear, it's very useful to have a coating, a PVD coating or something like this to reduce wear and galling. Yeah. Next, please. So let's take a look to some examples for DCMX. In this picture, we have a piercing punch. The customer was using at first standard D2 grade. And as you can see in the picture left, the customer has the typical problem of chipping at the cutting edge. He was using D2 with 59 HRC, and his tool lifetime was about 10,000 cycles. And then he used DCMX for the first time with a higher hardness of 62 HRC, and tool lifetime was more than 10,000 shots without chipping. I guess in the end it was a wear resistant. Yeah. Next, please. This is also absolute typical for D2 grade. The problem in this trimming punch was chipping at the cutting edge and also above some galling. And the customer was using D2 with hardness close to 60 HRC with a tool lifetime of 80 to 120,000 shot. Then he used for the first time DCMX with a higher hardness. And he had no problems with chipping, just as I can see here, just a slight galling, and the tool lifetime goes up to 200,000 cycles, and that's, I guess, it's very impressive. The next, please. A share blade is also a typical application for DCMX. As you can see in the picture on the left side, the customer had problems with chipping, a very early chipping after 3,000 shots. And the total tool lifetime with D2 was about 20,000 shots. And then he switched to DCMX with the same hardness, and the tool lifetime goes up to 88,000 shot. Also, perfect idea to use DCMX for this share blade. Next, please. Now we have an overview about different applications. They work all in the same way. We have in the first line a cutting blade, then a blanking die, and then 3 trimming dies. The strength was in the first line about 590 megapascal. And in the middle, the center pillar was about 780, a little bit higher, but a little bit thinner material. And the customer was using for the first time always D2 grade. In the first line, a modified D2 with 58 HRC. Then the next lines, D2 with 59, or for the center pillar, 61 HRC. And then he moved to DCMX. The hardness was always a little bit higher, but the results were always better. In the first line, he had no chipping, but the next trials for the blanking die, he had with D2 grade tool lifetime of 2,000 to 4,000 shots, and with DCMX he had 19,000 cycles. Impressive result. And the next results also very impressive. The trimming die in the middle for the center pillar. With D2 he had just 960 shots, and with DCMX the tool lifetime goes up to 33,000 cycles. Very impressive. And next two also very impressive, from 8 to 55,000 and from 10,000 to more than 100,000 shots. And I can tell you from my customer in Germany, we have also a lot of very impressive results with DCMX. I can tell you later a little bit more, maybe. Yeah. The next, please. Yeah, that was the presentation of DCMX. Does anyone has a question at the moment?
Yeah, there is some question. I will try to. The question is from my LinkedIn profile. You know, some customer asked me this question, so I will put it here. So it's a question for you, Matai. Are there any recommendations for cutting parameters in case of using the DCMX or steel grades from the Dream series?
At the moment, our recommendation is, if you want to switch to move to DCMX for the first time, it's the best way to use the parameters from the D2 grade. And if you want to use for the first time one of the Dream series, please use the parameters for the standard M2 grade. That means 1.3343. And as I told you before, at the moment we are doing some case studies, some milling trials together with our partner Mitsubishi. Mitsubishi is a very known manufacturer of milling tools, and the first results are outstanding, and I guess we will publish the results next month, and as soon as we have the results, we will publish them in our web shop, in our homepage. And if someone of you have interest, please send us an email, and we will share the results, of course, with you. And we are going to produce also a brochure where we will publish the results. Yeah, this is our recommendation for machining.
Okay.
Okay, I guess we should go back one slide.
Okay.
Yeah. So let's go into the Dream series. What's about the positioning of the Dream series? The basement is the M2, means 1.3343. You can see the M2 positioning on the orange line, orange area. And this is the basement for the Dream series. The Dream series is in general a modified 1.3343. The Dream 3 works very close to the strength, the hardness of M2. That means a hardness up to 66 HRC, but the toughness and the pressure resistance is much higher than with M2. The Dream 2 is a little bit closer to the DCMX. You can see the hardness is very close together. The Dream 2 works with a maximum hardness of 62, also up to 63 HRC, but the toughness is higher than with DCMX, and the Dream 1 is a little bit special. It's not a typical HSS steel. You can see the positioning is very close to the hot work tool steels. That means the hardness is limited up to 56 to 58 HRC, but the toughness of Dream 1 is extraordinary. It's the typical toughness of a hot work tool steel. That means Dream 1 is a mix between HSS and hot work tool steel, and it's very special. We have some customers, they use Dream 1 in case of if they work with a very thick material. Therefore, you need a little bit lower hardness and the best toughness you can get in this range. And Dream 1 is a steel they meets this requirements very well. Yeah. Let's go forward. What's about the chemical composition? You can see the Dream 1, 2, and 3 with the yellow marking. And over there, you can see the M2 grade. And the big difference, or the most important, is, of course, the carbon content. M2 has about 0.84% carbon. Dream 1 is very limited, up to 0.5. Dream 2, about 0.7. And Dream 3 has, I guess, the same carbon content as the M2 grade. The situation with the carbide building elements are a little bit different. Dream 1 has a little bit more of chromium and tungsten with 3%. And Dream 1, as I told you, is a mix between HSS and hot work tool steel. It has also a content of cobalt. That means that hardness in elevated temperature is higher. Of course, Dream 1 was designed at first just for forging applications. But as I mentioned, we have some customers, they need a very tough material for thick material, and therefore Dream 1 is really a perfect idea to use it with a hardness of 56 to 58 HRC to solve problems in the stamping process where you have a complicated and a critical shape. Therefore, Dream 1 is a perfect solution. Dream 2 is our newest steel grade with Recknagel Präzisionsstahl. We started in the market some month before. Dream 2 has a really high hardness of 62 HRC in combination with a very high toughness, and chemical composition is about 0.7% carbon, and the chemical carbide building elements are also a little bit limited, up to 5.5% for chromium, 2.5% for molybdenum, and vanadium about 1%, and tungsten also 1%. And it reached a hardness of 62 HRC. And the Dream 3, it's very close to M2 grade 1.3343. As I told, the carbon content is on the same level. The big difference is the Wolfram tungsten content. With M2 grade, the tungsten is about 6.3, and the content with DREAM3 is just 1.1%, and that means that DREAM3 is a modified HSS, modified especially for cold working applications. And let's go forward, please. Because of the ESR remelted state of the DREAM series, the microstructure of the DREAM series is very fine. DREAM1 and DREAM2 is almost free of coarse carbides, as you can see in the pictures. And because of the little bit higher content of carbon and carbide building elements with DREAM3, we have some fine linings, and we have also single coarse carbides, but the toughness and the pressure resistance of DREAM3 is much more higher than with the standard M2 grade. Let's go to the next, please. Yeah, what are the main applications of the DREAM series? Of course, as I told, for DREAM1, it's designed for warm forging, warm forming applications, but for if you use very thick material, it's good idea to use DREAM1 if you have problems with massive break, with chippings, and so on. DREAM2, from my technical view, it's the best steel grade if you need a high hardness of 62 HRC and the best possible toughness. This is really an outstanding combination of both requirements. You can use DREAM2 for every cold forming dies. We will see in the next slide, also for thread rolling tools. Yeah, and if you need a higher hardness of 66 HRC, DREAM3 will be the right choice. You can use the highest hardness. You can use also a very high toughness and pressure resistance. And I can tell you from my experience with DREAM3, I have a lot of customers. They were using in the past some powder steel grades like Böhler K390, Böhler S390, or Vanadis from Udeholm, Vanadis 4, 8, or 10, or from Era Steel. And they moved from PM grades to DREAM3. They use the same layer, the same coating, PVD coating. And I get a lot of feedback from my customers that DREAM3 with the same hardness of 66 HRC, with the same layer, is working in the same way as powder steel grades. Yeah, this is outstanding. And with DREAM3, if you want to replace powder steel grade, you will save a lot of money because DREAM3 is much cheaper than a powder steel grade. Yeah, let's go forward, please. Yeah, as I told, thread rolling dies are very special because normally you have always a problem with cracking of the tooth top. This is the main failure with thread rolling dies. In this case, the customer was using at first a typical 8% chromium steel with a hardness of 60 to 62 HRC. And the failure mode was early cracking after some minutes or a few days. And then he tried DREAM2 for the first time with a hardness of 60 to 62 HRC, and he has no cracking. And as I told you, DREAM2 is our newest steel grade in our portfolio, and we started some months before with the first trials also for thread rolling tools, and we are waiting for some feedback, and we are sure that Dream 2 is really a perfect steel grade for thread rolling tools because of the very fine microstructure, of the very high toughness and pressure resistance, and that's very important for the tooth of a thread rolling tool. Yeah. Let's go forward, please. The next application is cold pressing tool, and as you can imagine, there's a big problem with the hole, and the failure mode in this case was, of course, a massive crack, a massive break from the hole. The customer was using a high-speed steel, standard high-speed steel M2 grade with a hardness of 62 to 64 HRC, and he had, of course, a very early cracking, the early stage. And with Dream 2, the hardness, he bring the hardness down to 59 to 60 61 HRC, sorry, and the tool lifetime goes up to 390,000 cycles, and that's really outstanding. And that shows the extraordinary toughness of Dream 2 grade. Yeah. The next, please. This is a little bit special, an embossing roll. I could imagine this is maybe from a customer in Italy. I'm not sure about it. It's a cold rolling of celluloid material for food container. And in this case, it wasn't the goal to bring up the tool lifetime, because the customer was using a very expensive powder steel grade with a hardness of 60 to 62 HRC. And as you can see in the picture in the table, the diameter was very big, 120 millimeter, and the length of 550 millimeter. That means this tool is very expensive, and his focus was to save some money during the process, and he switched to Dream 2. The service lifetime was on the same level, but he saved a lot of money because Dream 2 is much cheaper than a powder steel grade. And this is sometimes, especially in this time, and we are in very critical times, a lot of my customers asking me always, how can we save money because the tool shop is not running as well. And I told them always switch back to matrix steel grades from Daido Steel, and you will save a lot of money. And this is a perfect application example how you can save money in your tool shop. Yeah. Please, the next. Yeah, that was
okay. Yeah, we are in the end, but we have some questions here. So thank you for these questions. I will start with one which I will try to answer it. So this is the question from Osama. Could you share some insights to reduce the particles, debris in high-speed stamping processes? You know, this is why speed stamping companies use carbide punches. However, that's why we are introducing Daido Steels today, because we are convinced that Daido Steels are replace carbide stamps in certain cases. But this is always a matter of testing. So try some of the Daido Steels and see for yourself how they perform. How much I say, if you use these carbide punches, they are very good, but they are also expensive. And we are convinced that the Daido Steels are able to be, equivalent for these carbide steels. So my answer is, if you want to avoid these debris and burrs, the carbides punches are the best. But if you want to have cheaper equivalent, so try to use Daido Steels. That's my answer for that. And we have another question for Matej, probably from you. Using the DCMX for several applications, building deep drawings, how does it compare to a shear blade made of S7? If we not be able to answer it, we will send you that on your LinkedIn profile. So maybe, so if you are able to answer it, Matej, now.
What exactly is the S7 grade? Is that's a little bit complicated for me, but because I don't know the exactly composition of S7. Is that a powder steel grade shear blade made of S7?
Okay, we will look at it. If you can send another question when you explain that, please send it. Now we have another question from you. I have expanded metal shear blades with a sawtooth profile, very harsh conditions, high SPM, high tensile materials. Okay.
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 Yeah, if you use SPM, I guess SPM is a powder steel grade with a higher hardness. Therefore, I can recommend just Dream 3 grade with a higher hardness. And you use your working material is 304 stainless steel. I could imagine that you have a problem with galling. Yeah. And therefore, you need a higher hardness of 66 with Dream 3. And also, it's very useful and helpful to use a layer, PVD coating or something else.
Okay. And now another question that I will answer it. Is this presentation available for future reference and application? Yes, of course. And I will put this presentation on my LinkedIn profile. Probably Matej will always put the presentation on his profile, so you can take it. It's not a problem.
Yeah, of course.
Another question. Liu, SPM strokes per minute. Okay.
Okay. Okay. Sorry.
Okay. And we have another question. Do you have a follow bar services for food industry and sheet cutting blades?
We have a follow bar service for food industry and sheet cutting blades. What does he exactly mean?
I think it means that if the Daido Steels have some certification for the food industry and so on,
Okay.
I don't know.
Yeah, of course. Daido Steel himself has, for sure, a certification or something as Regnagel Präzisionsstahl. We don't have certification for food industry. Yeah, but Daido Steel, of course. Yeah.
Okay, I have another question here, which I receive from my LinkedIn profile. It's here. Does it make sense to use a stress after rough milling or after hard machining?
If you use stress relieving yet, you can use it, of course, with DCMX or the Dream series. But I'm sure you don't need a stress relieving in general because the machining is so much easier. As you remember the picture of the chips, the color of the chips with DCMX was much brighter. That means the temperature during the milling process is lower. And so you have less stress in your part during the milling process, and that means you don't need in general a stress relieving, but you can use it. I guess it's important to get your own experience with stress relieving, but I think you don't need stress relieving in general if you use matrix 3 grades. Yeah.
Okay, and the last question is Do you have any cases about AHSS specifically about above 2200 megapascal and thickness of 6.6 millimeters for punches? Yes, we have these cases, and we use for this material, we use special punches, but I'm not able to answer you in this webinar. So if you send me this question, I will answer. I will send you exactly what sort of punches we use and from which material. But I think in this case, the Daido Steel will be excellent for that. So please, if you want to answer that more specifically, send me that question on my LinkedIn profile, and I will try to answer it.
I have also some experience with this high strength material. I have some customer, they use material with higher strength, up to 1017 megapascal, but the thickness in this case is very thick, 1.6 millimeter with 1200 is enough, much. And it's also very important to see the whole punch. It's not only the thickness of the material, it's also the shape. Is it a complicated critical shape? But therefore, normally we use always the Dream 3 grade with 64 to 66 HRC, because the very fine microstructure of Dream 3 is very important, and also the high toughness and the pressure resistance is helpful to get a good result for this high strength material. Yeah.
Okay. So, okay, thanks a lot, Momir. I was saying, okay, thank you very much. And okay, maybe, as I said, for another, for inquiries or collaboration opportunities, reach out to us via LinkedIn or email. We will answer you. Don't be afraid. And I think that brings us to the end of today's webinar. So I'd like to thank all of you for joining us and for your engagement. A special thank you to Mataj Denis for his excellent presentation and insights. Thank you very much, Mataj.
Welcome. Thank you, Moimir, for your organization. Perfect.
Yeah. Thank you very much. And we hope this session was valuable for you, and we look forward to seeing you again in our next webinar. So until then, take care and have a great day. Have a nice day. Bye.
Yeah. Thank you. Bye.
Bye. Bye.